Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
A box a box is sliding in a positive x-axis direction. It's sliding in this direction and is slowed down by a steady wind in a minus x-axis direction. This problem involves the graphical analysis. So the graph represents x of a t, the position of the lunchbox is the function of the time. So we fit the curve to concave down parabola, which is x of t is equal to 1 over 10 t 10 minus t, that is equal to t minus 1 over 10 t squared. By taking one or two derivatives, we find vt, velocity first and then acceleration, so which is dx over dt. If we take the derivative with respect to time for the given function of the position, which is 1, so this we get here. The velocity we get is 1 minus t divided by 5. This is in meters per second. And the acceleration we get here is a d square x divided by dt square, which will be equal to minus 1 over 5 meter per second square. Then further, the equation implies that the initial speed of the box is vi. V0 is 1 meter per second, and the constant force by the wind is F is equal to ma, that is 2 kg times minus 0.2 meter per second squared. This is equal to minus 0.40 Newton. The corresponding work will be force times x of t, that is 0 minus 0.04 t times the function minus t. The initial kinetic energy of the box then will be Ki will be 1 over 2 mvi squared, that is 1 over 2 times 1 meter per second squared, that is a 1 joule. Then we can write the change in kinetic energy. Change in kinetic energy will be Kf minus Ki, that is equal to work done. Then K of a t is K initial plus work, that is a 1 minus 0.04 times t 10 minus t. For part A, at time is equal to, so this is part A, for time t is equal to 1 second, the given expression for the kinetic energy, K for 1 second, becomes 1 minus 0.04 times 1, so 1 here, 10 minus 1. This gives us approximately 0.6 joules. Part B, at t is equal to 5 seconds, the kinetic energy at 5 seconds will be 1 minus 0.04 times 5, 10 minus 5. This will give us a 0. Part C, the work done by the force from the wind from t is equal to 1 second to 5 seconds is W is equal to K of 5 seconds minus K of 1 second. This gives us 0 minus 0.6, which is approximately equal to minus 0.6 joules.